Okay, so for the first one, this is like a recap of what we did yesterday. 2 times 3 plus 4. As you guys know, it's the same as 2 times 3 plus 2 times 4, because yesterday we said we had to distribute this 2 into everything inside the bracket. When I say distribute, am I talking about adding, subtracting, multiplying, or dividing? Claire? Multiplying. So yesterday when we had that negative sign outside, in a way, we were multiplying that negative sign inside the bracket. So that's why it was 2 times, so just like here, it's 2 times 3 plus 2 times 4. Keep that in mind. So when we do this one, example 3D, okay, Kavishan, if I do negative 3 times y, what do I get? Negative 3y. And then what is negative 3 times negative 7?
21.
Positive or negative? Positive, and so it's plus 21. Okay, remember yesterday, 2 negatives make a positive? Okay, let's try one more. Okay, for a 3h. So again, you're multiplying that negative 3 on the outside to everything inside the bracket. So what's negative 3 times negative 3p? Let's see. Hey, I'm gonna keep asking you, Kavishan, until you put away that phone. Right? Negative 3 times negative 3p.
9p.
9p, positive 9p. Good. And then what about negative 3 times negative 2? So I just write like this. Okay, well, I need to link the two terms together, so plus, right? Because it's positive 6, so I write a plus in between. Okay, so this is just exactly like what we did yesterday, but yesterday it was just a plus or minus sign outside and no numbers. Now that we have a number, we apply the same technique, so we're multiplying it. Number 5 right here, a communication question. So we have this 8 times 3x plus 4. So Natasha is thinking I have to do bed math. So I should add these two together to get 7x and then times. Is she right or wrong? Should she do bed math in this one and add these two terms? Vincent? Why not? And so what do we, so 3x and 4, we cannot combine them because they're unlike terms. So these are 3x and 4 are unlike terms. Okay, this is a proper terminology, like terms, unlike terms. Right? And because they are unlike terms, we cannot combine them together. Remember, 3 apples and $4, nothing in common, no connection. That's why we cannot group them. Okay, now let's try something a little bit more trickier. Okay, difference in this one is instead of a number, it's a variable on the outside. Okay, so again, we still do the same thing by multiplying in. Okay, multiplying the negative x in. Right? Negative x times negative 8. Move it. 8x. Good. So again, the sign applies, the sign rule applies. So you get 8x. Now here's the tricky part. What is negative x times negative 6x? Okay, Claire? 6x squared. Where did that square come from? Well, if I wrote it just at a side right here, if you think back to the beginning of this chapter 3, if I have something like this, all right, you know that this is like a negative 1. So then negative 1 times negative 6 is positive 6. And then x times x is x squared. All right. exponent rule. You add the exponents. So then it's 2. Okay, so that's why the exponent rules was the beginning of this chapter, and this is what I put into the practice quiz. Okay, so this is the only tricky part. When you multiply a variable with the same variable, you have to add the exponent. Okay. So in that case, what's this one then? Negative 2x times x squared. Eric? Negative 2x cubed. That's right, because of the 1 plus the 2 gives you the exponent 3. Okay, remember that exponent rule? When we multiply, we add the exponents. Okay, coming back. Okay. What's next? Okay, remember there's 3 terms in here. So then my next one is negative 2x times 4x. Vincent? Negative 8x squared. Good, because the x times the x gives me the x squared. And then lastly, negative 2x times 6. Genevieve? Negative 2x times 6? Negative 12x. Okay, good. Right, any question on this one? This is the trickiest one. Okay, if you understand this, you're in good shape. We'll do a couple of more of these type of examples. Okay. This one. Who wants to try this one? 7e. 7e. Okay, Eric. Good. So the 4 times the 2, I get that 8. But why am I not making it xy squared? It's not like terms, it's not the same variable. So what do? I just write it as 8xy. Okay, so no exponents. I can't add the exponents on them. It doesn't become xy squared. It doesn't become x squared y squared because they're not the same base. Okay, and then here, 4x times 3, as Eric said, 12x. Okay, and then I leave it like that. I cannot combine them because this one, even though there is an x, but this is an xy and this is just x. So I leave it. I cannot combine anymore. That's my final answer. Okay. Any questions so far? Okay. Number 8. You guys actually did a couple of these homework questions. It was in the homework, so I want to tick one of these up. Alright, so should I take away that phone? Okay, so let's focus. An emergency roofing repair company charges $120 for each visit and then $75 per hour. Determine an expression to represent the total cost of repairing a repair visit that requires T hours of work. So I don't like this question because it does say per and per right here. But here it's just saying the total cost of one visit. So then I know I don't have to worry about this per. $75 per hour. This is my T. Okay, this is where I put my variable. Okay, so $75 per hour. So 75 times T, or I can simply just write as 75T. All right, so $75 per hour is the same as 75 times T, or I can simply just write it as 75T. All right, so if I were to write an expression, okay, it's been in the homework. Claire, what did you write? Great. Okay, $75 per hour, and then on top, I have to add on that $120 one-time fee. Okay, on weekends and holiday, the total cost is double. Determine the simplified expression for the total cost of a weekend repair. Okay, so if it's double, how do I write it? How do I write it properly in proper format? Vincent? Excellent. Good job. Okay. So if the whole cost is doubled, that's why you're putting the 2 on the outside, and then the bracket is very important so that you're not just multiplying the 75. Okay. Determine a simplified expression. Oh, use your expression from part A to determine the total cost of a weekend repair that requires 1.5 hours. Does it ask you to determine a simplified expression? Okay. So if we were to expand this out, it'll be 150t plus 240. Right? Just multiplying it in. So if it takes 1.5 hours, okay, what's my cost? Jason, can you help me with this one? If I repair for 1.5 hours.
1.5 hours.
Yep. 1 hour, 30 minutes. Okay, what am I substituting in?
90 minutes.
Okay, so I should put 90 in here. Okay. So what does T represent again?
Hours.
Hours.
Around 1.5.
Right. Okay, so be very careful. Yes, I know that 1 hour and 30 minutes is 90 minutes, but you have to take a look at what your unit is. Because it's hour, that's why I put 1.5. Okay, and then plus the 240 setup fee, my flat rate, and then I get 150 times 1.5 plus 240, 465. Okay, full marks for this question, Vincent. Dollar sign, my units. Okay, no units, half a mark off. Okay, so again, similar questions was in your homework for the last 2 days. Okay, you have what you have to remember for these ones is read the question again, pick out the part where it says $75 per hour, or $5 per orange, or $10 per day. That is gonna be the variable part, and then the flat rate is the part that you just add on to it at the end. Okay, right, Uveen? Sorry, not right, Hannah? Okay, let's put that away. Okay. Let's see. Let's try this one. Let's see if you guys can do this one. I'll put it on a separate piece of paper so it's a little easier to see. Okay, 11F. Okay, if you guys can do this one, you will have no problem on the test on Tuesday. Okay, so this is 11F. 11F, 11F, 11F. I just rewrote it so that we have more space. Okay. Let's do it together. Okay, so first off, what am I going to do with that 3? Right, plug it in. How many times? 3 times, because there are 3 times inside the diskette. So multiply, multiply, multiply. Right? Why am I not multiplying it to everything out here? Yeah, right. This is after one bracket. This I have to do as well. Right? Um, this one is tricky because it's not written the same way. Usually we see the 2x in the front, but now we see it in the back. Does it change anything? No, you do the same way. So this multiply with this, and this multiply with this. Okay. So you can think of it as 2x times this, or you can think of 7x times 2x. Okay. It's the same thing. Again, you're multiplying it twice. Okay. So 3 times x squared. Let's see. Suhan, why don't you work with me on this one? 3 times x squared. Good. Okay. 3 times 5x. 15x. And then 3 times negative 3. Excellent. Okay. Right here. 7x times 2x. 14x squared. Okay. And then 4 times 2x. 8x. Am I done the whole question? Why not? Add the like terms. That's right. What we did 2 days ago. What goes with the 3x squared? The 14x squared, and that gives me. Okay. What else can I combine? And that's. And remember, a common mistake that people do. Okay, now that they multiply and then they change some of the the exponents, when they add, it doesn't become x4. Remember. Okay, I know that there's times when you change the exponent and when you don't change the exponent. I'll go over that in a bubble in a second. And then lastly, we have this -9 that doesn't go with anything else, and I have this. Is this my final answer? Yes. Okay. Can't do anymore. Can't group them anymore because this is the Tesla, this is the Toyota, and that's money. All right. Don't mix. Okay. So one last one I want to go over. Okay. One last one. 18E. 18E. So as I said, I am doing quite a few examples today because there's no easy way to explain this. It's just you need to keep practicing these questions so that you get used to it. Hey, this question looks scary because it's a fraction. All right. What's my denominator here? Claire? 2x. So my denominator, I can actually separate this and write it as 24x squared over 2x minus 16x over 2x. Okay, so I can separate my denominator into the two. Right? Just because there's an x doesn't change how you've been doing fractions. Okay. And then again, going back to our exponent rule, when we divide, what do we do to the exponent? Yeah. Minus, right? So 24 divided by 2, we get the 12. X squared divided by x, you mean x, yeah, just x, or x to the 1. And then what about here? 16x divided by 2x. Hannah, what do you think? This one? This part? 8x. Is there still an x? Oh, no, 8. Yeah, just 8 because the x cancels out, or you can think of like 1 minus the 1, so it's gone. So minus 8, and that's it. Okay, I just wanted to go over this one because some of you forget that when you have a one denominator, you can split it back out into two separate fractions. Okay, so let's do a quick little summary right here. I'll do a little bubble. Okay, if you can remember these couple, you'll do perfectly fine on the test. We'll do A, apples. What is one apple plus one apple? Yeah, 2 apples, so 2A. Okay. What about pineapple plus a pineapple? Clear? 2 pineapples. Okay. It doesn't become a gigantic one. Okay, so it stays as a square. If you're just adding the same type, you're adding the same type. It doesn't change to a different type. When does it change? When you multiply. Okay. A times A. What's A times A? Clear? A square. This is when it changes. Okay? It only change your exponent only changes when you are multiplying. It's like you are it's mutated. So your apple, when you mix it with chemical with another apple, it becomes that. It becomes um, an orange. Okay, or avocado. It becomes the apple becomes the avocado. Okay, and then what? And then what about? See, again, you're mixing it, you're multiplying it. Okay, what's the apple times the avocado? What does this become? Yep, a cube. Right, so again, when you multiply, that's when it becomes something else. When you're adding and subtracting, you keep it the same type. Okay, one last one. What is this? A plus a square. Okay. Jason, what do you think? Tricky question.
That's just A plus 3 square.
Good. Why can't I mix them?
Because it's plus all time.
Right, it's an adding. Remember what we kept saying? It has to be the same type. So if here, they're not the same type. They're unlike terms. So I cannot. Like, Suhan?
Yeah, sure.
Oh. Oh, Shikai. Oh, sorry, my bad. I thought they want you again today. You're popular today. Okay? So if you can remember these 5 right here, you should have no problem with the tests on Tuesday. A lot of times, it's not that the math is hard, but some people just get confused of when does it change and when it doesn't change, when the exponent. So here, hopefully this little chart, this little bubble, these 5 examples will help you remember, will help you remember. When you're adding and subtracting, it has to be the exact same type. When you're multiplying, then you apply your exponent rule. Okay? Any question on today's lesson?